through an instructional routine you can use with the Unit 6 Day 3 Lesson 2A. Our focus question for this lesson is, what does it mean for a pattern to be growing quadratically? And throughout the lesson, students will really be exploring these quadratic patterns. However, for our warm-up, we want to give students a chance to kind of just start thinking about how to represent images and patterns using expressions. So this warm-up is using the instructional routine, which one doesn't belong. Students are given this image and they must choose which one of these expressions does not belong by analyzing the image. After this slide, you'll see on slide 14, students are then challenged to identify another expression that might not belong. So similar to the instructional routine we did before, you can use Jamboard to allow students to share their responses. And so you might not get as many different responses justifying why each one doesn't belong as you would for a notice and wonder, because it's a little less open-ended, but it is still quite open-ended where you can have varying levels of understanding being shown here, and students have access at many different points. And so again, students can go ahead and put a post-it note to justify which one they've chosen does not belong, and then they can agree with each other. If, say, they had the same reason or a similar reason, they can check that off. And so, for example, when you're then going to go, you'll give students a couple minutes to work on this, and then you'll come back together and you'll review it. And if you look through, you can see that there's a slide for each one justifying why it does not belong. So when going over this, you really want to push students to understand the connections between the expressions and the image using this prompt to get them thinking. So when we're looking at this first slide and we're saying, well, why doesn't expression A belong? We see that some students are really pointing to that this is the only expression that involves subtraction. It shows taking out part of the larger rectangle. And this one even says it doesn't make sense to find the total, you would need to add. And so here's where we might ask someone to show us and annotate and justify, where do you see, somebody who thought expression A belonged, where do you see expression A in this image? And so again, this is where annotation becomes really, really helpful for students to visualize. So I'm going to grab the pen and I'm going to pick the color blue. So a student might say, well, I see expression A as the entire rectangle is 6 times 8. Oh, okay. So 6 times 8 is right here. And we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then what's happening in this second part where we're subtracting? Well, we're subtracting out this little rectangle right here, because that one is taken out of the original 6 by 8 rectangle. How do we know it's 6 units? Well, we see it's 2 by 3, right? 2 by 3. So this one definitely is an option that doesn't belong, and it makes sense why a lot of people chose it. However, we can still see that there is a connection between the image and the expression. Now let's take a look at expression B. There might be a little bit less responses of people thinking that this one doesn't belong, but we still see some answers. So this person says it splits the rectangle up into 2 rectangles horizontally. And this person said this is another way of writing expression C. Interesting. Can someone explain this part right here? How do we see the connection between expression B and this image? What do you mean by horizontally? Okay, well, we can grab the pen and we can either have a student annotate or we can annotate for them while they speak. And we're seeing that 4 times 8 is 1, 2, 3, 4, 5, 6, that's 6. 1, 2, 3, 4, 5, 6, 7, 8 times 1, 2, 3, 4. So we have from here to here as that first part of the expression. Splitting it up horizontally, we draw a horizontal line through it, the rectangle, through the figure to make it into 2 rectangles. And then we have the 2 times 5 here. Beautiful. So we can see that connection again. I'm interested in this part. How do you say that this is another way of writing expression C? And if you have someone who's like super advanced with the vocabulary, they might say, expression C shows us repeated addition, and we know repeated addition is the same as multiplication. We have, or something a little simpler, right? We have 4 groups of 8, and we're adding it to 2 groups of 5. Beautiful. Okay, so just a simplified way of writing that expression. So that takes us over here to expression C. And I see some people talking about expression C. They're saying this is the only one that adds repeatedly. That makes a lot of sense. It's the only one that has 2 numbers, right? And we talked about this last time, but this is a lower level response, but it's still correct. Why does it only have 2 numbers? Well, it's just adding the 2 sets of the 2 rectangles widths together, right? And this is okay to accept as an answer and to value as an answer. And we come back to this point of B and C being equivalent. But what do we know about all of these expressions so far, A, B, and C? What do they all equal? They're all going to equal 42, so they're all equivalent expressions in some way. And maybe that's another challenge. How can we look for more connections between different expressions? We see B and C. Can we find other connections? Okay. And we can even go ahead and show expression C here and show, that we have 8, 8, 8, 8, and then we have the 5 and the 5, right? And then finally, expression D. This person is pointing that it's splitting up the shape vertically. This doesn't have a match, right? It doesn't have one as closely matching as these 2 were, right? And we see the 5 by 6 and the 3 by 4. So this one also splits it up into 2 different rectangles. And so for this specific question, you wouldn't necessarily have time, right? This is just a warm-up. You wouldn't have time to go through every single slide and annotate and really show the way that I'm showing right now for a 30-minute period. But you might just choose to pick one, and maybe I'm going to pick one that either has the most responses of why it doesn't belong, or the one that has the least responses of why it doesn't belong, and ask students why they felt that expression best represented the figure. Or I might really want to focus on either C or B, because I could see that connection between those really easily, and that's something that is going to help students as we move forward. And then as an extension, I offered on here for students who might be finished early, can you come up with another expression to represent the image, right? And so you could have 1 plus 1 42 times. We have 3 groups of 2 times 5 plus 3 times 4. There are an infinite number of expressions students can create, and this is a great extension activity, especially for students who are going to finish really early, to get them to really continue to thinking about how to represent this image using algebra, using expressions. Okay? And so after completing this warm-up, now we're going to transition into continuing to think about patterns and representing patterns and images using algebra, using mathematical language. And after that warm-up, you would then go ahead and transition into the explore activity for today, where now we're seeing a pattern, we're representing it, and we'll continue to think about how to represent that pattern numerically. Thank you for listening.